Good morning, everybody. My name is Shubham Mure, and today I will be presenting the Cloudburst prediction system that I have made using the machine learning. So, it is a part of my machine learning course at SPIT, and it is my mini project. So, the project is divided into three parts. First is visualization, second is the prediction part where I will be training the models, and the third part is model deployment where I'll be using the model to dynamically test if the cloudburst will appear or not for a particular set of data. So in the first part I've used pandas and numpy and used matplotlib for plotting the data. So I've plot these are the plots of various datas. First is for wind gust speed, second is for pressure, third is for cloud, fourth is for maximum temperature observed, fourth is temperature at 3 p.m., and fifth is humidity against the date axis. Now moving on to the second part. First we are importing the cloudburst data from the CSV file, and we have more than 1,45,000 records. So if we see the information regarding all of the data that we have, we see that there are two types of data types that we can observe. First is of float and the second is of object. But to train the models and to find the correlation, we have to convert this object data type into some numerical value that we will do further. Next we see the null values corresponding to the each feature that we have. We have the aim of converting this number to zero either by using some kind of algorithm or by simply removing the column if we don't need it. So data processing is done for two types. First is handling the missing values, and second is to removing less affecting attributes. So we start by removing a few of the attributes that we don't want. uh, Second is converting the object values into numeric values using the label encoder. Next we see the null values after dropping a few columns, and we find the after the converting from object type to numeric type of data, we are able to find the correlation between various attributes. From this table we see that the correlation of the output that we want, which is cloudburst today and cloudburst tomorrow, is less for a few attributes, so we remove them. So we remove minimum temperature, evaporation, wind speed at 9 a.m., wind speed at 3 a.m., and temperature at 9 a.m. Now we again, after dropping, we again see the correlation, and we now we are dropping those records which we have null values for sunshine, humidity at 3 p.m., cloud at 3 p.m., cloud at 9 p.m. We see a few values, few features having zero null values. Now for remaining features we apply KNN to find the missing values. uh, Now we have reduced the number of rows from more than 1,45,000 to 64,000, which is again a huge number of records to train our model. Now we have no missing values. We have successfully pre-processed the data set with that we have, and since we are predicting two values, that cloudburst is happening today and for tomorrow, so we are storing it in two variables, y1 and y2. Now for modeling we have to divide our data set into the two parts, that is training and testing, to avoid the issue of overfitting. So the ratio that we are dividing is 7 is to 3, that is we are using 70% of our data set for training the model and 30% of the data set to validate our model. So We are using four algorithms. The steps that we are using for each algorithm is basically the same. The first step is to import it from sklearn library. The second step is to fit the model using the training data set that we have, and the third step is to calculate accuracy, precision, and recall from the test data set that we had divided. So the first algorithm is support vector machine. We see that the accuracy is pretty good. Now we save each of the model that we are training, we are saving it into our local storage using some name, so that we are able to use it further in the model deployment phase. We do the same for tomorrow. The second algorithm is random forest. The third algorithm is logistic regression, and fourth algorithm is naive based. Now moving on to the next phase, which is model deployment. So I've used Gradio for deploying the model, and these are the parameters that it takes to predict if the cloud burst will happen or not. And this is the function that does all the job to show the result. This is how the user interface looks. So the user has to input various data fields, and once the user enters the data field, you can submit and check if the cloudburst will happen today or tomorrow. In the case of this data, the cloudburst is happening. Now if the data values of these inputs are changed, there is a chance that the output will also change. So the output dynamically changes based on the input. So that is it for our project. Thank you.